Assalamualaikum class. In today's lecture we will discuss what are the operations that can be implemented on binary tree and an application of binary tree. We can define different operations on binary trees. If P is pointing to a node in an existing binary tree, then left of P will return the pointer to the left subtree, right of P will return the pointer to the right subtree, and info of P will return the content of a node. Notice that left of P, right of P, and info of P is the operation or function of a binary tree. For the construction of a binary tree, the following methods are useful. Set left, pass P and X. It will create the left child node of node P and the child node contain the info or data X. Set right function will create the right child node of node P and the child node contain the info X. X can be any data. Now let's move forward toward an example or application of binary trees. A binary tree is a useful data structure when two-way decision must be made at each point in a process. For example, suppose a user wants to find all duplicate in a list of numbers. One way of finding duplicates is to compare each number with all those that precede it. Let's see it in detail. Suppose we are looking for duplicates for the number 4. We will start scanning from the first number 14. While scanning, whenever we find number 4 inside, we remember the position and increment its frequency counter by 1. This comparison will go on till the end of the list to get the duplicate or frequency of the number 4. You might have understood already that we will have to perform the whole scanning of list every time for each number to find duplicates. This is a long and time-consuming process. If the list of numbers is large and is growing, then the procedure that is explained in the previous slide involves a large number of comparisons. A linked list could handle the growth, but the number of comparisons would still be large. We can reduce the number of comparisons if we use binary trees. The tree grows dynamically like the linked list, so it can handle growth. While searching for duplicates, we are going to build a binary tree in a special way. The first number in the list is placed in a node that is designated as the root node of a binary tree. Initially, both the left and right subtree of the root will be empty, and we will take the next number and compare it with the number that is placed in the root node. If that number is the same, then we have a duplicate. If that number is not the same, then we create a new node and put the new number in it. The new node is made the left child of the root node if the second number is less than the one in the root node, and the new node is made the right child if that number is the greater than the one in the root node. Now let's solve this example step by step. We will start with the first number, that is 14, and we will place this number in a node, and we will mark this node as the root node of a tree. As you can see that it is not pointing to any further node, therefore its left and right pointer are null. Now let's take second number, that is 15, as the first step to add a new node in a tree. We take the number 15 from the list and compare it with the root node, that is 14. The number in the root node and the number 15 are not same, as they are different, so a new node is created and the number 15 is set into it. The next step is to add this node in the tree. We compare 15, the number in the new node, with 14, the number in the root node. As the number 15 is greater than the number 14, therefore it is placed as right child of the root node. The next number in the list is 4. We will compare 4 with 14. Both numbers are different and 4 is less than number 14. 4 is less than number 14, so we make the node 4 as the left child of node 14. At this point there is no left child of root node, so we can add 4 as the left child of root node, that is node 4. The next number in the list is 9. To add this number in the tree, we compare this number with the root node. The number is found to be smaller than the number in the root node. We will move forward toward the left subtree of root node. The left child of the root node is the one with the number 4. On comparison, the number 9 is found greater than the number 4. Therefore, we go to the right child of the node with the number 4. At this moment, there is no further nodes to the right of it. So, we will create a new node with number 9 and we add the node 9 as the right child of the node 4. The next number is 7. We are going to compare 7 with root node 14. 7 is less than 14. We compare 7 with node 4. 7 is greater than 4. We move toward the right subtree of node 4, that is 9. 7 is less than 9 and the left child of 9 is empty. So we will add a 7 as the left child of node 9. The next element in the list is 18. 18, we compare 18 with 14. 18 is greater than 14. Now we will compare 18 with 15. 18 is greater than 15. Now we will add 18 as the right subtree or right child of node 15. The next element is 3. The 3 is less than 14. We compare 3 with node 4. 3 is less than node 4. The left subtree of node 4 is empty, so we're going to add 3 as the left child of node 4. The next element in the list is 5. We will compare 5 with 14. 5 is less than 14. Now we will compare 5 with 4. 5 is greater than 4. We will compare 5 with 9. 5 is less than 9. And now we will compare 5 with 7. 5 is also less than 7. So 5 will become the left child of node 7. The next element is 16. We are going to compare 16 with root node 14. 16 is greater than 14. We will compare it with 15. 16 is greater than 15. We will compare it with 18. 16 is less than 18 and the left subtree of 18 is empty. So 16 will become the left child of node 18. The next element is 4. 4 is also a duplicate. We will compare 4 with 14. 4 is less than 14. Now we will compare 4 with node 4. Here is the duplicate. So we will discard 4 and display to the user that we found a duplicate 4. The next element is 20. 20 will become the right child of node 18. 17 will be added as the right child of node 16. The next three numbers are duplicate. It will be discarded and displayed as a duplicate number on screen to the user. We will compare 9 with 14. 9 is less than 14. Then we will compare 9 with 4. 9 is greater than 4. We will compare 9 with 9. Both are same. So we will discard 9 and display as the message on the screen that 9 is a duplicate.